Welcome back, guys. So today we'll be continuing again something that every C++ programmer should know. Okay, so firstly we'll start off with pairs. Okay, so what is pair? In simpler word, pair is a container that contains two heterogeneous values. What do I mean by heterogeneous? I simply mean that it contains two different values. Like array vectors, they are homogeneous because they can only contain a single type of value, right? Suppose when you are declaring a vector and you name its type int, then all the value of that vector they will be of type int, right? So that is mean by homogeneous. Now by heterogeneous I mean that pair actually contains only two type of values. All right, only two. That's why it's a pair, right? Pair means two, and those two values they can be same or they can be different. It's up to your choice. All right, so how to declare a pair? It's pretty simple. All the data structures in STL, they have pretty much same way of defining, because this is actually the way of defining a template in C++. I hope you know what a template is. So let's start. Firstly, you have to write the keyword pair, and after that, I need to basically data type that you want. So I'll just make a char and int, and I'll just name p pair. Okay. Now, how do you insert the value? There are only two primary operations: how to insert them and how to print them. So the first and the most easy way is p dot first. Since it contains only two value and it's a given thing, so you can just write first and you can just write second. P dot first means char and p dot second means an int type value. So I can just pass a, and for second I can just pass, let's say, 12. And printing them is also the same way. Just print p dot first and print p dot second. You have to just use these two keywords, first and second, and that's all that you need to know while you're using pairs. Okay, let's see if it runs or not. Okay, I'm sorry, I thought that I encountered an error, but all right, a and 12 it prints. I didn't print any space. Okay, so that's it. We are done with basic operation of printing, and there are other way of defining an element in pairs also. Suppose you don't want to use first and second in order to you know give values to pairs, so you can also use this way also. Just this parenthesis way we use it in vector also, I believe. Okay, so first element is, let's say, a, and after that you just have some 23, and this is another way of basically initializing a pair with some values, and if you print it, it will again get printed a and 23, right? And suppose if you don't even want to prefer this way, because every time you won't know the value from the start, right? Every time you would have no idea like how what will be the value. So there's another function that you can use, and it's pretty easy. It's just make pair function. So you can just use this function make pair, and you can just pass any two values that are of this form, like char and int, and it will make a pair for you. Instead of using first or second, you can just do this, and I personally prefer using this way. So I'll just pass b and let's say 23, and I'll run my code. Okay, all right, I didn't use semicolon. Now let's try to run this again. All right, b and 23. So you might be wondering that pair, it seems quite useless, but it's not. I hope you remember that how we made a vectors of 2D vector. We made a vector of vectors, and pair is also meant to be used in such a way. You just have to use this alone. It might seem a pretty bit useless, but combine it with other data structures and it can do wonders. So there's no need to worry about it. But pairs can be very useful. You use it in map, you use it in unordered sets also. There are very other ways of using pairs. So keep this in mind, and it will come pretty useful for you. All right, now moving on. The other thing is, every time you study trees and graph, you will definitely encounter these two data structures. So first of them is stack, right? What is stack? Stack is sort of a data structure, linear data structure, which follows the format of LIFO, like last in, first out. Basically every element that you push, it will the first element that you push, it will be the last element that will be popped out. I hope you have studied stack, because every time you use recursion, you are introduced to the concept of stack, right? So let's also see the basic operation of stacks. Again, how to initialize a stack the same way, and it's also a template. Write the keyword stack and the type of data type you want, so I'll just say int and s. So we are done with the definition part of stack, and now how to use it. Okay, using a stack is pretty much simple. The operation names are also the same: push and pop. Push is for inserting values and pop is for removing values. So let's just say I push 1 and I'll just push 2 and 3. So what push operation does is it's basically insert the values in a LIFO manner. Every time you print a value, sorry, every time you push a value, it gets inserted and it becomes the last element. So when you push, when you print this element, this vector, it will be printed in the form of firstly 3 and after that 2 and after that 1. Because stack uses a top pointer and top pointer always points to the last value that you insert. Now, how do you print a stack? Okay, so for that you must know a few functions, and those are the function empty. It returns a boolean value and it checks whether your stack is empty or not. Okay, and you need to know this. And the other function is top. Top will return you the most top value. That's it. And now how do you print a stack? Okay, so I'll just have to check this condition while s dot empty. Till the time my stack is not empty, I'll just keep on iterating, keep on going on this loop till the time it's not empty. Okay, and after that I'll just print the top value s dot top, and after that I'll just pop the topmost value. Sorry. Okay, now let's see what our stack is. We inserted 1 2 3, and when we print it, we'll get the order 3 2 and 1. Okay, so this is your stack. Now how to check the size of stack? It's pretty simple. You just have to use the function size. You have used this function also in vector also. It will return you the size of stack, queue, or whatever you use. So if you just print s dot size without passing any parameters, it will return you the size of your stack. Okay, so these are all the basic operations of stack, and you can use them in graphs and trees. And since we are talking about graphs and trees, the other most important data structure that we will be using there is queue. So queue is also a linear type of data structure which follows the FIFO manner. FIFO means first in and first out. Okay, most of the things between stack and queues are same, however the fundamentals are different. Queue basically use 2 pointers, unlike stack. Stack only use 1 pointer, and you know that because stack only used 1 pointer, that is top. But unlike it, queue uses 2 pointers like front and back. Okay, so now again, how to initialize a queue? I hope you already know how to do it. Queue int queue. Okay, and how do you insert a value inside queue? So for that you need to know a basic function, that is push. It's the same as stack. And how to remove the value? It's also the same. You just need to use pop, right? However, the function that they perform here is different. When you used to pop there, suppose you were inserting values like this: 1 2 and 3. Okay, when you used to pop in stack in the first element, then the 3 will get popped, right? Because top will be pointed to this. But if you're using pop here, then 1 will get popped because it follows a FIFO manner. Okay, now how do you use push? Q dot push. Let's say 5, Q dot push 6, and Q dot push, sorry, 8. Okay, we are done with inserting values in the queue. Now how do you print it? It's also pretty simple, but before that I'll just no, I'll pop it later. Okay, so for that also you need to know a few more functions, and those are empty, the same as stack. Alright, I told you most of the functions between queue and stack are same. Empty will return me a boolean value which states that either the queue is empty or not. If it's empty, it will return me true, and if it's not, then it will return me false. Okay, so I'll use empty, and I'll also use front. Front will return me the first value, like since we have already inserted 5, 6, and 8, then our queue will look like this: 5, 6, and 8. Then front will be pointing to 5, and back will be pointing to 8. Let's just try to firstly print it to get you a better idea. Okay, q dot front and q dot back. The names have a meaning, so it's pretty easy to learn it, right? Q dot front endl. Endl just acts as a new line. Okay, cout q dot back endl. Now let's print it. I think q dot front will return me 5 and q dot back will return me 8. Let's check it out. Yeah, right. 5 and 8. Okay, so first was front and second was back. Okay, so now we will be displaying. Sorry, now we'll be actually printing all the values of q. So how to do that? It's also pretty same like how you did it in stack, right? So while till the time q is not empty, we'll just print the first of q. Okay, and we'll just pop it, q dot pop, and this will work enough. Q dot front space, and let's now try to run our code. 5, 6, 8. Okay, so it works great. All right, so these were all of the basic operations of queue. I hope you have an idea of now how to use stack and queues. You will generally use both of these data structures in different sort of questions. Like you can use stack when you encounter a question like this, that you have to check whether this order of braces is correct or not. I hope you have seen such sort of questions, where you check whether this order of braces is correct or not, and you have to check if it will give you an error. Okay, and you also use stacks and queue in many different data structures like trees and graphs. Okay, now queue also has many different features. You can use priority queue. Priority queue basically what it does it's basically it sorts the table, sorts these elements that you enter every time, and every time you print the front, you'll get the largest or the smallest value depending on your comparator. So queue can be modified also in different ways. And when you're using stack, when you're using bfs, when you're doing dfs, when you're using bfs, I think you use queue. When you're using dfs, you use stack. So those are all again the applications of stack and queue, right? And these two are also very important data structures. And we have also looked at how pairs works. Okay, pairs, they can do actually, they can really do wonders when you use them with other data structures. You have to just combine them. Okay, so this was all for a second part, and we'll soon make maps, unordered sets, unordered maps, and sets for different part. Okay, so thank you.